mathematicians, we're going to work through an application word problem together where we're going to take information about this real world situation and describe patterns with expressions, think about what questions being asked and describe that, model it using an equation, solve the equation, and then use the solution to figure out how we can actually answer the question. So I've just done a little thinking ahead of time. First of all, these problems seem short and simple, but remember, math is about thinking slowly and deeply, so don't rush these problems. I find a good thing is to always draw some kind of diagram. So I first started with, let's just read the problem bit by bit now. First. Okay, so pause me and read the problem and then come back. Okay, so the first thing I read is that Robin Banks robs a bank and takes off in a stolen Toyota Camry at 2 kilometers per minute. I think you'll enjoy the names from these problems. Robin Banks is robbing a bank. So here he is at the bank and he goes off 2 kilometers per minute. Now, somebody at the bank must have maybe called the police or somebody because 5 minutes later, Willie Ketchum leaves the bank in pursuit of Robin. So I have that in purple. So Willie has a couple things about him. He gets to the bank 5 minutes after Robin has already left, and he takes off 5 minutes later, and he's traveling at a speed of 3 kilometers per minute. So we have sort of 3 different patterns going on here. So one of the next steps I do is I want to describe each of these patterns using a variable expression. And to do that, one technique I use, and there's so many different ways to do this, is I'm going to collect some information in a table and use that to generalize to get my expression. So first for Robin, I know for Robin, I want to be able to input time, how long has he been driving, and output his distance. So my input to the table is going to be Robin's time, and that's in minutes. And the output is going to be Robin's distance, and that's going to be in kilometers. So let's just start. After 0 minutes, how far is he from the bank? He's 0 kilometers. After 1 minute, he's driven 2 kilometers, so he's 2 kilometers from the bank. After 2 minutes, he's 2 more kilometers from the bank, so he's 4 kilometers. Notice every minute that goes by, we're adding 2 more kilometers, starting to see that pattern. So how about after 10 minutes? Let's see, after 10 minutes, he started 0 miles from the bank and has gone 2 miles 10 times. So 2 times 10, he's 20 kilometers. And after X minutes, he is X times 2 or 2X. All right, awesome. So we have this nice little pattern. If we let our variable be Robin's time, then his distance can be described as 2X. Okay, for Willie. So Willie's interesting. Willie has 2 patterns. The first pattern is between Robin's time and Willie's time. So we're first going to input Robin's time in minutes, and then output Willie's time in minutes. Okay, Willie doesn't even get there till Robin's been driving 5 minutes. So after 5 minutes, Willie's been driving 0 minutes, and he's at the bank. After Robin's been driving 6 minutes, Willie's been driving 1. And after 7, Willie's been driving 2. So maybe here it's a very simple pattern. Every time we need to start with Robin's time and subtract 5 minutes. So if Robin has driven X minutes, Willie's driven X minus 5 minutes. Awesome. Once we have Willie's time now in relation to Robin's, we can think about Willie's distance. And that's this third pattern, Willie's distance. This is in kilometers. And we know Willie is going 3 kilometers per minute. So after he's been driving 0 minutes, he's gone 0 kilometers. After 1, 3 kilometers. After 2, 6 kilometers. So every time we go up a minute, we're going up 3 kilometers. So after X minus 5 minutes, he's gone 3 kilometers, X minus 5 times. Okay. And here we have, again, in terms of Robin's time, our variable, here's Willie's time, and here's Willie's distance. So everything now is in terms of a single variable x, which is Robin's time. So that's actually, I'm going to write this right here. Let x equal Robin's driving time. All right, so I think we have a good feel for describing the different patterns in this problem using variable expressions. But our last step now is, how long will it take Willie Ketchum to catch Robin Banks? And I know he's going to catch him because even though Robin gets a head start, Willie is driving faster, so he's going to eventually catch up. Now, we know he's going to be caught. Here's Robin driving. Here's Willie driving. He's going a little faster, and eventually they're going to catch, which means they have driven the same distance from the bank. So now we need to have an equation to model this. When are their distances the same? When is Robin's distance the same as Willie's distance? And because I have this single variable that's Robin's driving time, that's why I need to use Robin's driving time for both of those patterns. All right, let's solve it. Oops. I'm going to first distribute. I'm going to subtract 3x from both sides. Did you catch my error? Should have been negative 15. I'm going to divide both sides by -1. And I now know that when Willie catches Robin, Robin has been driving for 15 minutes. So if Robin's been driving for 15 minutes, we know that Willie's been driving for 10. So Willie catches Robin after 10 minutes, driving for 10 minutes. I hope nobody was hurt in that driving. All right, so seemingly simple problem, but it does take a lot of slow and careful thinking to first think about what are the patterns that are in this problem, how can we describe those patterns using expressions, what's the question being asked, and how can I model that question in an equation that I can solve and use the solution to answer the question. All right, mathematicians, you're going to be solving a lot of these application problems. Please, 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 please ask questions. You'll make lots of mistakes, which is great. So make your mistakes, ask questions, and I'll see you soon.